Hello grade 9 students. Let us continue our lesson on the properties of quadratic functions, particularly identifying quadratic functions. Before our lesson proper, let us first have a warm-up. So number 1, evaluate x squared plus 5x for x equals 4 and x equals negative 3. So first, we substitute the value of x, which is equal to 4, to x squared plus 5x, and also with negative 3 to x squared plus 5x, and then what will be our answer if x equals to 4. X equals to 4, we have 16 plus 20, which is 36, and negative 3 squared, 9 minus 15 is negative 6. How about here number 2, generate ordered pairs for the function y equals x squared plus 2 with the given domain. Domain negative 2, negative 1, 0, 1, 2. Yes, you substitute these values of x to the equation y equals x squared plus 2 to generate the ordered pairs for the given function. To solve for the value of y for each x coordinate. So the answer here for negative 2, 6, negative 1, 3, 0, 2, 1, 3, and 2, 6. Because if we substitute negative 2 here, that means 4 plus 2, we have 6. When we substitute 1, we have 1 plus 2, 3. 0, 0 plus 2, 2. 1, same as here, 3 and 6. Okay, so the function y equals x squared is shown in the graph. Notice that the graph is not linear. Of course, the graph of a linear function is only a straight line. So as you can see here, the graph is a smooth curve, which is called a parabola. So parabola is what we call the graph of a quadratic function. So a quadratic function is any function that can be written in the standard form y equals ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0, because if a is 0 and multiply it to x squared, it becomes 0, and then it will return to its linear function. Yes, it will go back to being a linear function. So the function y equals x squared can be written as y equals 1x squared plus 0x plus 0. So in this particular equation, b is 0 and c equals 0, while a equals 1. So this is the graph of the quadratic function y equals x squared. Excuse me. So let's continue. So how did we get this graph of the quadratic function y equals x squared? Of course, you will assign values for x, substitute it here, and then you can form up the table of values. Then you're just going to plot the points, and you will find out that the vertex is at the origin. Yes. Okay, so notice that the quadratic function y equals x squared has constant second differences. Okay, we've already discussed this in the previous lesson. So for the first differences in the x values of quadratic function, they are equal. Constant change in x values. Also, for the y values, for the first differences of the y values of quadratic function, okay, they are not equal. As you can see here, we have 1, 3, 5, 7. But if we're going to subtract the first differences of the y values of quadratic function, then we will have equal differences, equal second differences, I should say. 2, 2, 2, 3 minus 1, 2, 5 minus 3, 2, 7 minus 5, 2. Yeah. So that's one of the characteristics of a quadratic function. It will yield equal first differences in x, and it will yield equal second differences in y. So let us identify the given table of a function, if it's quadratic or not. Tell whether the function is quadratic. Explain. We have here the values negative 2, negative 9, negative 1, negative 2, 0, negative 1, 1, 0, 2, 7. Okay. So as you can see, equal differences, equal first differences for x. How about y? Negative 9 here. 0 minus 7, negative 7. Negative 1 minus 0, negative 1. Negative 2 minus negative 1, negative 1. Negative 9 minus negative 2, negative 7. So, the first differences for y are not equal. How about the second differences? So, for the x, equal differences. So, since you are given a table of ordered pairs with a constant change in x values, see if the second differences are constant. Find the first differences, then find the second differences. So, 7, 1, 1, 7. Not equal. But, you're going to subtract the first differences. 7 minus 1, 8. Here. 7 minus 1, 6. 1 minus 1, 0. 1 minus 7, negative 6. Not equal. So, the function is non-quadratic because the second differences are not constant, or they're not the same. They're not equal. So, this given table of values function is not quadratic. How about here? Tell whether the function is quadratic. Explain. By the looks of it, the highest exponent for the variable x is 1 only. So this is not a quadratic function, but a linear function. Since you are given an equation, use y equals ax squared plus bx plus c. So this is not quadratic function because the value of a is 0. Yes. When a is 0, as I've told you, it will go back to its becoming a linear function. How about here? Tell whether the function is quadratic. Explain. Y minus 10x squared equals 9. Yes, it is a quadratic function because the highest exponent for the variable x is 2, so it's second degree equation. So let's first try to write the function in the form y equals ax squared plus bx plus c, which is a general form, by solving for y. Add 10x squared to both sides. It will become y equals 10x squared plus 9. So by the looks of it, there is a value of a which is 10, b 0, c is 9. So this is a quadratic function because it can be written in the form y equals ax squared plus bx plus c, where a equals 10, b equals 0, and c equals 10. So the graph of a quadratic function is a curve called a parabola. So from the figure, it's a parabola that opens downward. It can also open upward. Now use the table of values to graph the quadratic function y equals negative 4x squared. So make a table of values, choose values of x, and use them to find the values of y. So for negative 2, negative 1, 0, 1, 2, for the values of x, let us solve for y. Substitute x here. Negative 4 times 4, negative 16. Negative 4 times 1, negative 4. Negative 4 times 0, 0. Negative 4 times 1, negative 4. Negative 4 times 4, negative 16. Then grab the points, then connect the points with a smooth curve. So So as you can see, the graph opens downward. Why? Because the value of A is negative. A is less than 0. So if A is less than 0, then the parabola opens downward. But if A is positive, then it will open upward. How about here? Use a table of values to graph each quadratic function. Y equals x squared plus 2. Make a table of values, choose values of x, and use them to find values of y. Yan, negative 2, negative 1, 0, 1, 2 for x. Let us solve for y, when x is negative 2, 4 plus 2, 6, 1 plus 2, 3, 0 plus 2, 2. Yes, 1 plus 2, 3, 4 plus 2, 6. Grab the points, then connect the points with a smooth curve. So as you can see, the graph opens upward because the value of A is positive, or A is greater than 0. That will make the opening of the graph or the parabola upward. When a quadratic function is written in the form y equals ax squared plus bx plus c, the value of A determines the direction of the parabola opens. Yes, that's what I was telling you about. The parabola opens upward when A is greater than 0. The parabola opens downward when A is less than 0. So if A is positive, parabola opens upward. When A is negative, parabola opens downward. Tell whether the graph of the quadratic functions opens upward or downward. What's your answer? First, write the function in the form y equals ax squared plus bx plus c by solving for y. So, you transpose negative 1/3 x squared to the right side of the equation. So, it will become y equals 1/3 x squared plus x minus 3. So, what's the opening of the graph of this quadratic function? The answer is, I first identify the value of A, which is 1/3. 1/3 is positive. It's greater than 0. So, therefore, the parabola opens upward. So, basta pag positive yung A, parabola opens upward. How about this? Tell whether the graph of the quadratic function opens upward or downward. First, write the function in the form y equals ax squared plus bx plus c. Just interchange the position. Negative 3x squared plus 5x. Identify the value of A, which is equal to negative 3. Negative 3 is less than 0. So, the parabola opens downward. Okay? Can you understand? So, the highest or lowest point on a parabola is the vertex. If the parabola opens upward, the vertex is the lowest point. If the parabola opens downward, the vertex is the highest point. Makes sense, right? Here, if A is greater than 0, the parabola opens upward. Yes, you know that. And the y value of the vertex is the minimum value of the function. That means if the vertex is negative 3, 0, the minimum value is 0. Okay? And since A is positive, it opens upward. Here, the A is less than 0, negative 1, so it opens downward. So the y value of the vertex, the maximum value of the function. So the maximum value is the y value of the vertex, which is 3, 5, therefore 5. Maximum value of this function is 5, while the minimum value of this function is 0. The y value of the vertex is the minimum or maximum of the given quadratic function. So as you can see, here the graph opens upward because A is greater than 0, positive 1. Here, negative 1, so the parabola opens downward. Now, identify the vertex of each parabola, then give the minimum or maximum value of the function. Okay, from the graph, you can identify easily the vertex. For letter A, what's the vertex? Answer, negative 3, 2. Negative 3, 2 is the vertex. That means the minimum is 2. Here, the y value of the vertex, the minimum value. Here, since this opens up downward, it has a maximum value. Now, what is the vertex? The vertex is at 2, 5, therefore 5 is the maximum value of the given quadratic function. Check it out. Identify the vertex of each parabola, then give the minimum or maximum value of the function. It's the same as what we did in the last slide. For this, we have negative 2, 5 for the vertex. Therefore, 5 is the maximum value. Maximum, because it opens downward here. It has a minimum value because it opens upward. What is the vertex? 3, negative 1. Therefore, negative 1 is the minimum value of the function. Okay? Can you follow? It's not so hard. Let's continue. Okay, what's this? Parabola opens upward. So for the graph of y equals x squared minus 4x plus 5, the range begins at the minimum value of the function where y equals 1. So the y values, so all the y values of the function are greater than or equal to 1. So the range is y is greater than or equal to 1. Okay. How about this? Find the domain and the range. Step 1, the graph opens downward, so identify the maximum value. So the vertex is negative 5, negative 3, so the maximum is negative 3. Yes. Step 2, find the domain and range. Domain, all real numbers. Sorry. The domain of quadratic function always are all real numbers. All real numbers. While the range is, since it opens downward, y is less than or equal to k, which is equal to negative 3. Okay, the y coordinate of the vertex of the parabola is k, which is negative 3. So if it's going down, the range is y is less than or equal to negative 3. But if it's going up, y is greater than or equal to k, which is the y coordinate of the vertex of the parabola. Next, tell whether each function is quadratic. Explain. For number 3, here. Okay, this is your quiz. For number 3, identify if this given table of values is quadratic function or not by getting the first differences of x and the first and second differences of in y. For number 4, 5, 6, determine the domain and the range. Domain of quadratic function, all real numbers, while the range is y is less than or equal to k when the parabola opens downward. When the parabola opens upward, y is greater than or equal to k, or the y coordinate of the vertex of the parabola. So for your quiz, part 1, is y equals negative x minus 1 quadratic? Explain. No, there is no x squared term, so a is equal to 0. So that is not a quadratic. How about number 2? Graph y equals 1.5 x squared. Yes, assign values of x, solving for y in this original equation, then plotting the points, then connecting the points to make a smooth curve called parabola. Lesson quiz part 2. Identify. Number 3, identify the vertex. You can see there that the vertex is 5, negative 4. Does the function have a minimum or maximum? It has a maximum because it opens upward. So what is the maximum value? It is actually the y coordinate of the vertex, or the value of k, which is negative 4. Find the domain and range. The domain, all real numbers, while the range, y is less than or equal to negative 4, or the k. Y is less than or equal to k because the parabola opens downward. If it's upward, y is greater than or equal to k. So that ends our lesson on the properties of quadratic function. I think this is part 2. I don't know, is this part 2 or part 3? I'll see you again on our next lesson. Goodbye.